So we would like to do number 13 and 11.7, which says carbon-14 decays at a rate of 0.01245% per year. 5% of the C14 remains in some plant something. How old is this something? Okay, so what do I use for these? Okay, the PERT model. Okay, so what does the PERT model say? So P of T is P0 ERT. Okay, so let me populate my model with a little bit of stuff. What did they say? Oh, they gave me a rate. Okay, so let me cram that in there. So populating my model, P of T is, I'll leave that space blank. Can I put something in for the E? No, that's a number, man. Leave it there, right? Okay, what's the rate? 0.01245?
No, it's 1.2. Yeah,
5%.
I thought it was 5%.
So this is the decay rate, right?
Oh.
That means I need to convert that to a number, right? Okay, 1, it's negative, yeah, because it's decay. 2, that's a percentage. I need to convert it to a straight number for it to go in here. So it goes in as
1.245. Oh, because we're just getting rid of the fraction. We don't want to turn it into a decimal form. I mean, a fraction.
so what does 0.01245% mean? It means this over 100, right?
Right.
You guys see that? So if I'm thinking about this, I'm thinking, oops, black, color. Decays means negative sign. This guy means 0.01245 over 100. So the over 100 moves the decimal point 2 places to the left, right? 5% is 0.05. 10% is 0.1, right? You guys see that? So I got to do that same thing here, even though that number's already small. This is maybe the hardest part of these. Okay, what else do I need?
The
T?
time is 1 year.
Okay,
No, per year.
time is in years, yeah. But right now I'm just populating my model. So my model says population is a function of time, right? So this thing should include a t in it. You guys see that? Because I should have to put a time in. How about the initial amount?
We don't know that yet.
We don't know that yet.
100%.
They tell us 5% remains,
It
right?
would be 100% to be.
Yeah, so the thing I'm talking about is percentages. So I might start with 100. Okay, now they're telling me 5% remains. So what does that mean?
Said it's equal to 0.05 or 5.
Yeah, so is it 0.05 or 5?
0.05.
Move 3
So
times.
how much did I say there was to begin with? 100%, right? So I set it equal to 5. Or I could say there was 1 to start with, in which case I set it equal to 0.05. Right? That's your model choice. I made a model choice. I thought here, start at 100. Right? That was me. If you start at 1, then on the left-hand side you'll put 0.05. So I'm going to say I started with 100. So 5% of 100 is 5. And this is going to equal 100 e to the Why am I putting this stuff over here?
Would you have to multiply
Yeah, because I'm saying, okay, when did the model reach 5% of what it started at? You see that? And then we'll have to divide by 100 anyway. So we may as well have started this thing at 1, right? So I divide by 100, I'll get 0.05 is e to the minus 0.001245 times t.
Put everything into the natural log.
Okay, so now I want to get rid of the e, right? Or I could think I want my t down. Either way. So I should take a natural log of both sides. Okay, so I get
Natural log of 0.05.
natural log of 0.05 is negative 0.001245 times t. So then how do I solve for t?
Divide by negative
Okay, so I divide by this whole mess, negative 0.001245. Okay, so I get t equals what?
natural log of 0.05 all over negative 0.001245.
Okay, so that's my hard answer, right? But I'm doing a model, so this is an approximation anyway, and this is not a good number of years, right?
No.
Okay, so what do I get when I punch that in a calculator? Remember to close what?
Parentheses.
The parentheses that you put in for the log, right? Because you don't want to take the log of 0.05 divided by that thing. You want to take the log of 0.05 and then divide by that thing.
2,000 or 24,062.1. 0. 6.
Thanks.
Yeah. 0.1. 0.106.
I don't think I'm going to put months in my carbon dating. You guys see that? Oh yeah, and that was dumb. This is really a squiggle, right? And this is an answer in years. If I was going to answer the question that was asked of me, is that the thing I circle? No. Why?
This is not a
Yeah,
complete answer.
this was a word problem, right? They asked how old is the plant, right? So I got to write a sentence which should say,
The thing is 24,000 years.
yeah,
That's crazy.
it's about 24K years old. And probably the K is bed form, so 24,000 years old. You guys see that? Why am I okay with the kind of rounding thing here? Yeah, because I was going to say about anyway, because it's a model, right? It's not actually 100% accurate, right? It's just a model.
It's our current best efforts.
Yeah, this is our best effort. Yeah.
Can you use this model, or would you use a different model to solve, like, if you were tracking through generations, and not just like specific set years, but like actual whole generations? Like if you were tracking something in like genetics, would you use that, or would you use something else?
It depends. This is about the simplest model. And remember, this model applies when you can say the phrase, the rate of change of the something is proportional to the size. If that statement's true about something in genetics, yeah, this model will work. If that statement's a little bit wobbly for that item, then this thing won't work.
This is what we would use, like, if we want to see how long our tires are gonna last.
No, tires are a linear decay function, right? The rate at which your tires wear out is just proportional to the miles you've driven.
Yeah, and it's a pain in the ass.
Right, there's no to the amount of tread on the tire. It's not like they wear faster as they go in. Does that make sense? So that statement about proportionality isn't true there.
Okay.